Adriano Franchini, and my topic is about the information modeling for building automation toward the integration of BIM tools in robotic fabrication and 3D process. My supervisor was Bruno Figueiredo and Paulo José Cruz, and the tutor in company was Pedro Andrade. So just to start the introduction about this topic, this started because the problem of not the problem, but the necessity of the evolution on the ISC sector, the architecture, engineering, and the construction sector, to increase more the productivity, innovation, and sustainable practice, because they constantly demand for researches, the growth of the population. For it, you have some transformations happen on this sector. One of these is the BIM, where they integrate the project phases and extend the building life cycles, and of course, increasing the integration with the different stakeholders. In other side, you have the robotic automation, when you start to increase the quality and optimize the productions of the manufacturing process and increase the possibility of the construction and reduce the human errors and integrate with it. You can use the 3D concrete printing because it's totally connected with the automation with robotic, and it brings more flexibility, faster, and standardization on the process. And you can start to work with more complex geometry without reducing some problems on the executions of this. And at the same time, it's necessary to create a workflow to connecting these different process on the same building life cycle. So in this project, you go discussing about how these connections happen. So to start about it, the objectives of these dissertations is how the integration of BIM, 3DCP, and the robotic fabrication happen. And for it, you developing a BIM driving framework when you can create a computational model, so generative design. And the generative design will integrate this BIM, the robotic fabrication, and the prototype. And at the end, how this interoperability happen. So for it, you're using a study of the case based in a prefabricated system, a fabrication system of facades, and you can produce a prototype. Just to explain how is divided this dissertation, you can say the first time, the number one on this image, is the state of the art when discussing the different parts of this topic. The part two and the part three is definitions, like how the creation of this framework, how this methodology you happen. And down is the workflow, the final workflow, and how we separation. It started with the computational model, the generative design, and after this you have these breakdowns from the robotic programming and the creation of the prototype, and the other side, the interoperability with B. And at the end, you have the discussion and the conclusion. Just to start, the BIM and the IC industry is totally connected because BIM is inside of sometimes of the IC industry. The possibility of being inside of the industry is increase the coordination, the cost efficient, and the quality across all project phases. And of course, one important thing of being when we integrate the building data in the different phases and with the different stakeholders of the project. In the case of the automation in BIM, is a technology you can increase the parametric and the generative design and optimizing the processes and productions inside of the BIM and inside of the sector of the construction sector. And you can using this to check the possibilities at the real time. Some of the challenges when you are using BIM in this integration is mostly the problem with the interoperability and how the different data can be exchanged with different software tools. To try to solution this, you have the use of EFC, and the Building Smart can improve the interoperability, and there are a cohesive workflow. In the case of being and prefabricated system, this integration used with some system or with automation and software, and you can use this to optimize the final construction process. So just introduce a little about the generative design and the automation robot. The generative design process, they work with, in general, 5 or 6 steps. The first step is the compulsion ID creative, and use it to innovation the solutions. They create algorithm approach to explore design alternatives and a problem solving, using this algorithm approach to solving the problem you have before. On the case of the computational models, you have this interactive process. You can adjust in the real-time simulations to verify how this work on the process. In the case of dynamic adjustment, you can verify the feasibility and the performance about this design you create. Just on this image to illustrate a simplified how is working the question of the generative design, design goal, algorithm, design constraint, and the solution. On the part of the automation of robotica, uh, this increases the precision and the efficiency on the project. On your case, you are working with a robotic arms, and you have the integration with BIM, but you have the same problems with the other integrations when you use different softwares. You need create specific workflows, and you have some gaps when you have this exchange of information between the different softwares. Just to introduce a little more about the 3D concrete print, it increases the creation of the complex structures and some design freedom. Of course, you need to respecting the characteristics of the material and the robotic, but this at the same time is increase the velocity when you have many constantly or semi-project creation. So this is really good because you reduce the human problems, the human errors, of course, but they don't take off the human from this the algorithm because it's necessary, but it reduce on the production. In the case of the integration with 3DCP with BIM, you have the problem with the interoperability and the same time the construction, the necessity of construction a specific workflow. And this is at the same time is the problems and the solutions you need to use the different plugins, you need to use different softwares to connecting the different topics to work, Just to explain, normally there are the two technology using the for the extrusion. The first one is the infinite break extrusion, and the second is layer pressing. So use the pressures to create these extrusions. In this image, it's just to explain the layer pressing and how it's working normally in a small laboratory. So about the prototype, you work with a company, the Blue Fab is a company from Group Casais, and they use a Cree system overview, is a hybrid construction, and of wooden concrete, and they use a prefabricated system. On this case, you are working only with facades, so you create a new design of the 3DCP under the facade is some requirement of the company, because normally when you use a 3D CP concrete is outportant, you construct through the necessity of other support, but in this case, you did this the printing under inside of this prefabricated facade to create a design inside there. So this is the first framework you create when you can see on this framework how these different environments work together. So you have the first there, the being environment and robotic programming, and you have the generative design work between the both program. On this dissertation, working more with these two environments, but on the real life, on the construction site, you have this part of the offsite construction, you have this part of the cloud based, where is happen is the interoperability, the stakeholder. So, but I was working more where you can see the red lines and how these connections happen. Uh, After this, the creation of the framework, you create this software configurator to understand how this framework will happen on this dissertation. No? So you have it starting from being authoring tool, the Revit, and using the Grasshopper because the flexibility of the Grasshopper are designing creation. So you use the Grasshopper to create the code, and they are not compatible software. So use the one inside the Revit to create this connection and to create the geometry inside of Grasshopper and export it to Revit, and at the same time export the robot program from the cook a PRC with your other plugin, and after this, directly to the robot and create the prototype. Down the image is the diagram process, so the construction, how this workflow will happen on the process. So you can see one side the inputs and the other side is the output. So you have as the most important input will be the B model, ER, BAP, and the constraints, and you have the controls, limitations, specifications, and output is the results. Now you have the AFC file, the prototype, and the results. So this is the workflow general. So you are divided from just generative design, visual programming learning, language robotic, interoperability, and prototype. And I go explain this in little time now. So you start this with generative design. So we start the code. This is the first part of the code. And you select the facade. You can see the facade there is the facade from the gravity model. So you select the facade, you select the perimeter of facade. And with the selection, you start to realize the subdivisions of the geometry. And with this subdivision on your remote lines, you create the new curves, and these new curves on the future will be the two path of the robotic programming. So in the last image, you can see this 3D image when you be the printing. I just go send this to understand more how the generative design starts. Now you selecting the surface and go step by step till the creation of the new geometry based on the necessities of the robotic programming. So when you finish there, just come back. You have this toolpath created this on generative design. You select this and you connect it with the robotic visual programming learning language, and you create the toolpath where the robot will be this print. On this image, you can put the velocity at the next step, the velocity of the sprinting, how it's connected with the toolpath, and you can do the simulation with this, with their feasibility or not. You need to analyze it before to do on the real life. When you finish all this analysis, you export and to create the prototype. So on the part of being, I create after the linear geometry, I try to work to methodologies to export one more simple and directly, using just to create a direct geometry using parameters inside on Grasshopper and create director Habit. But when I do it, I can't access the natives parameters in Habit. So the methodology one was not the better one, but is the fast one. And on the methodology two, you can see you can put more parameters and you can put more information, more data to for the interoperability. So in many times this the second is better. But of course, it depends the necessity of the project and the necessities of this case. But the difference between the both is more because the second I create a new habit family, so you have more flexibility to work with it, and the first is just as geometry inside of Revit, and you are limited. On the case of exporting it, you have this create of the some property sets, and you did analysis between the same methodologies, how is better. On the first methodology, when you analyze it with other softwares, you see some limited data. In the second methodology, you see more information data, more possibilities to increase and to uh, put more information that depends of the necessity of the project. So the part of the prototype implementation, you need to create a small new facade element because you have some limitations on the robot. So you can see on the right side, you have this limitation and you do the simulation of the movements and you see the new toolpath. On the second image, you see the extrusion process when create based on the initial uh, geometry, generative design. On the prototype, you can see the analysis and some issues you have because the choose of this generative design. So like you can see some issues about space was not completely covered and something you need to create maybe in the future different designs and different possibilities to analyze how solve these problems on the future. About the result discussions and future directions, you can see you can see this efficient improvement and this design flexibility in using it. And you can see the capacity of the integrate these different processes together. So you can see the integration being robotic and 3D CP. But of course, you have some limitations about because the design constraints and maybe the algorithm adjustment. Now you need to increase the algorithm to create more complex geometry and to have more time to uh, work with this, and you have some interoperability constraints depend of the software you are using and of this prototype. So just there you can see some future research for it. So in generative design, you can work more with complex geometries, optimize solution and optimization plugins. On the case of the robotic model, is more like standardization, a creation of some hires. In the part of the being interoperability, you can improve more have the templates, export it directly from generative design. In many times it's not necessary you have a being authoring tool. You can be directly, but I choose this methodology. On the case of the prototype, you need to create different designs. You need to try different prototypes to do the comparison. Just to conclusion, but the key points of this, you can see the integration of the BIM with the 3D concrete printing and robotic manufacturing. You can see the designing flexibility, construction efficient, and the interoperability. And when you create this prototype implementation, you can see this feasibility in the future reports. And the initial project I was using a prefabricated system, bigger, and I implemented this in a different scale. So it can prove the possibility to work with the same generative design with different scales. So I think is this with someone have some doubts or something, maybe too much, a few time before share too much, but